OSHA's Hazard Communication Standard, or HCS, is based on a simple concept that employees have both a need and a right to know the hazards and identities of the chemicals they are exposed to when working. They also need to know what protective measures are available to prevent adverse effects from occurring. In order to be able to quickly and easily obtain chemical safety information, you'll receive both general and department-specific HAZCOM training before you are expected to work with chemicals. The Hazard Communications, or Right to Know standard, was enacted to ensure chemical safety in the workplace. It ensures your right to know which chemicals are being used in your workplace, the possible dangers you could be exposed to, and how to protect yourself and others while using them. OSHA categorizes the risks faced by employees working with or around chemicals into two categories: health risks and physical risks. Physical hazards are chemicals that can cause a fire, explosion, or some other violent reaction when they come in contact with air, water, or other chemicals. Chemicals that may be harmful to a person's health are called health hazards, which can enter the body in one of four ways: inhalation, when they are breathed into the lungs; skin contact, if absorbed through the skin; ingestion, when taken in by mouth; injection, if skin is punctured by a contaminated sharp object. These chemicals can cause short-term, acute health problems or long-term, chronic health problems. Contact with corrosive chemicals causes immediate and permanent damage to the body. Splashes in the eye or even droplets or mists can cause blindness, and inhaling corrosive chemicals will destroy the internal lining of the respiratory system. If a corrosive compound comes in contact with skin, the damage can be extensive and irreversible. The measurement for chemical corrosiveness is referred to as the pH. pH measurements range from 1 to 14. Corrosive chemicals have a pH less than 2.0 or greater than 11.0. In contrast, water is a neutral chemical with a pH of 7. Consult the chemical's SDS to determine corrosivity under physical and chemical properties. Then look for its pH in the list of chemical properties. Costco employees frequently work with corrosive compounds. Forklift batteries and car batteries contain sulfuric acid, which has a pH of 1.5. The chemical used to clean the ovens in the food court, Grease Strip Plus, has a pH of 13.5. Employees working with forklift batteries or cleaning the ovens in the food court must wear a chemical-resistant apron, forearm-length rubber gloves, and chemical-resistant goggles. There are two readily available sources for information on chemical hazards. First, the chemical's hazard label, required on all original chemical containers, and the chemical's safety data sheet. Let's review these two chemical information sources. The Global Harmonized System, or GHS, includes criteria for the classification of health, physical, and environmental hazards, as well as specifying what information should be included on labels of hazardous chemicals and safety data sheets. A chemical's hazard label has 6 required sections. Product identifier, the manufacturer's name for the chemical. This name must be the same on the SDS. Signal word, a relative measure of how bad the chemical is. Danger and warning are the two signal words. Danger indicates a more hazardous chemical than one that has a warning signal word. The signal word must be the same on the SDS. Pictograms, the pictogram applicable to the chemical. We will discuss each pictogram in just a minute. Hazard statement, standardized phrases describing the nature of the chemical's hazard. Precautionary statements, standardized phrases that provide information on what measures must be followed when using the chemical. Manufacturer information, name, address, and phone number for the chemical's manufacturer. Let's briefly look at these hazards groups and their pictograms. We will start with health hazards. Skull and crossbones are used to signify chemicals that are acutely toxic. The exclamation mark pictogram indicates hazardous chemicals which are generally non-fatal, such as skin and respiratory irritants. The Starman, or health hazard pictogram, identifies chemicals that are cancer-causing or toxic to critical human systems or specific organs. The corrosive pictogram indicates a physical and health hazard, as it can cause skin corrosion and/or damage to the eyes and respiratory system. Now, let's look at physical hazards. Exploding bomb pictograms signify hazards that may be explosive, self-reactive, or an organic peroxide. The flame pictogram identifies chemicals that are flammable, self-heating, flammable gas emitting, self-reactive, and organic peroxides. The flame over circle pictogram will denote only oxidizers. The gas cylinder pictogram will only be used to signify gases which are under pressure. If you transfer a chemical from the original container into a secondary container, the secondary container must also be labeled with very specific information. Your manager will show you how to access the secondary label directly from the intranet. Per the globally harmonized system, every chemical has a corresponding safety data sheet. It contains information on the chemicals and how to protect yourself from their effects. You will also find information on storage, handling, disposal, and specifics on the chemical's physical and chemical properties. You have the right to view any chemical you work with. If you would like a copy of a specific SDS, ask your manager or supervisor. As part of HazCom training, you will have access to the Understanding an SDS poster, which is mounted on the safety bulletin board in the employee break room. This poster provides a brief summary of the components of an SDS so that you will understand how to read and interpret one.